Hello and welcome back to a new video. Today's talk is going to be about generics or generic types in Kotlin. We're going to look at them and going to learn how we can make use of them. First, let's just take a look at a function or a predefined function that uses generics. So whenever you want to create a list, you would say val list is equal to list of. And within these diamond brackets, you will have to specify the type of elements that you wish to store within this list. So here ints, and here I'm gonna just enter my int values. Now let's just look at the implementation of this function. And I know this might be overwhelming at first, but let's just understand what it does. So just a function that has declared a generic type. So this is how you declare a generic type. And it takes a vararg of elements of the same type. And finally, it returns a list of the same type as well. So what's the purpose of having a generic type within this function? So without this function, we would have to make multiple functions for every data type that we have that return a list for us. Even the classes that you make. So whenever you create a class or a type, you would have to create a function that returns a list of that type. So you might say, why not use any instead of a generic type here, as any is the parent class for every class in Kotlin. Let's discuss this with an example. So we're gonna recreate this function together, and we're gonna make it any instead of a generic type. So here I'm gonna say fun my list of, it takes vararg of items of type any, and finally it returns list of any. And here I'm going to say return items.as list. So this is our original list that uses generics, and here I'm going to make another list from my function. So my list is equal to my list of. I'm going to have the same values 1, 2, 3, and 4, and this list here does not use generics. Cool. So we added our values, nothing is wrong, everything works. But whenever we use the values that we stored within these two lists, problems start to appear. Now let's just try to calculate the sum of all the values within our list here that uses generics. So I'm going to make simple for loop for I in a list, and here I'm going to make just a sum. You have to create a sum before, so for sum is equal to 0, and here I'm going to sum, so I'm going to say sum is plus assign the I. And finally, we're going to say println the sum. So as you can see, the first list that uses generics, nothing is wrong with it. Now let's do the same for our any list. So var sum2 is equal to 0, and for I and my list, sum2 is plus assign the I, and finally we println the sum2. And here we can see that we have an error because we don't have the plus assign operator for any class, because any items that you added to the list are considered to be any, and if you check the type of this list, it's just a list of any. So to handle this, we have to cast the I to be an integer in order to add it and assign it to the sum2 variable here. So I'm going to say I as integer. Now it works, and now we are able to access the plus assign operator. Now let's just run the program to verify the result, and we are going to get 10 for the first list that uses generics and 10 for the second list that does not use generics. The only difference that we had to cast the value before we try to access any of the type functions. But say for instance, if we added a string, so I'm here in the first list, I'm going to add a string, and it gives us an error at compile time because the list expected only integers to be added, but we added a string. But for the second list, if we added a string, nothing will be reported, no warnings at all. And now if you run the program, we'd have a terminating error because you cannot cast a string to an int. So we're going to get a class cast exception. You cannot cast a string to an integer. So the first benefit of using generics is that you don't have to cast, so generics help you avoid casting. The second thing is that is a type safe, so it provides a type safety. So whenever you try to enter any type rather than the specified type, it will warn you before you run the program, unlike using a list of type in. Now let's modify our function to make use of generics. So the first thing that you would do is to declare the name of your generic right before the name of the function, and you would do it with a diamond bracket. So here you just type the name of your generic. You're allowed to enter anything, any name, but the naming convention for the generic types is just a capital letter, and usually it's T. Now I have declared my generic type name. Now I'm going to use it here. So item is of type T, and it returns a list of T. Cool. Now let's just specify the type of arguments or the type of items that we wish to store within this list. So here I'm going to say the items must be of type int, and here we got the warning because we're not allowed to enter strings in a list of type int, so I'm going to delete it. And finally, I'm going to delete it. And finally, you'd see that the casting is redundant since every value within the list is an int, so we don't have to cast. And now it will work just as before, and it's pretty similar to the original function right here. And now I'm just going to make another list, or I'm going to modify my list here to accept type string. And here I'm going to add strings as well, so I'm going to make a sentence. Hello. Also make sure to assign your sum2 variable to a string to concatenate strings within this variable. And I can see that our list is flexible with other data types as well. And if we run the program, we will get the sum of these four strings, or the sentence, hello, this is astroc. And you could also do it with other data types like double, just to verify. I'm going to make it so quickly. And here is the result, 17.3. What you could also do with generics that you can add some type of constraints to the type passed to some kind of function, for example. So say for instance we want to print the values in some list, and we only want this list to have integers or doubles or just numbers. So to do that, we'll just add the same function or make the same function. So fun, we specify the generic type, which is T, and we say print numbers, and just take a list of type T, and it doesn't return anything. So what we're going to do is just want to say for every number in the list, now please print the number. Now our function here in its current form accepts any data type. We didn't add any constraints. So let's just first try the function. So I'm going to say print numbers. I'm going to give it first a list of integers, 1, 2, 3, 4, and then I'm going to give it a list of strings. So string, maybe test here, and string 2. And if we run the program, nothing is wrong, everything will work. Now let's just give constraints to our function. So when I say the list of that type must be of type number. So here I'm just going to say the T here, or our generic type, must inherit from a class called number. And the class called number is just a superclass for any numeric values in Kotlin. So this is the parent class of doubles, float, long, int, char, short, and byte. And here you could also see, if we get into the double class, you'd see that it inherits from number class, as well as the float and the long and the integers. Let's just get back to our main function. And as you can see here, the compiler gives us an error because the string class doesn't inherit from its string number, so we cannot pass it to the function right here, which requires us to pass a generic type that inherits from number. So we're going to delete it, and we're only going to pass values that inherit from numbers, so 1.5 for a double, maybe 1.7f for float, more integers, 200 be 1.7f, and we run the program. Generic types don't only work with functions, they also work with classes. So let's just create a class that accepts a generic type. Class, I'm going to call it generic class, and here I'm going to specify the generic type, so T. And I'm going to open the constructor. I'm going to have one property of type T, value of type T, and finally I'm going to have a simple function that returns the T or returns the value. So fun get, it just returns the T here is equal to the value. And whenever we create an instance of this class, we have to specify the type. So generic type is equal to generic type, and here we specify string. Then we open the constructor and we pass our value. So here I'm going to pass string test. And lastly, we can also access the value with the get function. So I'm going to say println generic class dot get. And if we run the program, we will get this value in the constructor right here. Now you can notice that the compiler will infer the type of the generic. So whenever you add the type or whenever you specify the type in the constructor like this here, or the value of the type, then the constructor will infer the type, so you don't have to add it here. Now that was a simple example. Let's have more practical example. So I'm going to make a class that converts two lists to a map. So the first list is going to be the key, and the second list is going to be the value of that key within the map. So here I'm just going to create the class. I'm going to call class is called map creator, and this class right here accepts two generic types. The first one is going to be T, and the second one is going to be E. You can name it anything. And now I'm going to open the constructor of this class, and here I'm going to accept two lists of type TE. So private val list of type list first list. I'm going to name it first list of type list of T. Then private val as well, list 2 is of type list of type E, and then we're going to open the class body. And now we're going to have a simple function that converts these two classes to a map. So fun get map, it doesn't take anything, and it returns a map of type T for the keys, E for the values, and it might be null. Now, first we're going to check if these two lists are in the same size. So if list1 dot size not equal to list2 dot size, then we return null because we cannot convert this to a map. Now, if this is not the case, then we make a for loop here. And first we're going to take any of these loops or any of these lists. So I'm going to take the first list. I'm going to say for list1 dot for each indexed. So here I have the index of the position of the value and the item of the value. Cool. Before the for index or before the for loop, I'm going to make a map. It's going to be a mutable map. I'm going to be empty first. So val map is of type or is equal to mutable map of, going to be the same for the key and the E, which is the value. Now, first we want to make the list one as the keys. So I'm going to say map, and here I'm going to add the key, which is the item on the list one. So here I'm going to pass the item, and this item is equal to the list 2, the item at the index of list 2. So these two lists must be the same size, and whenever we loop or whenever we iterate through the first list, then we map the first item to be the key to the first item of the second list to be the value, and whenever the loop is done iterating, we return the map. And here let's try our class. So we're gonna make instance map called creator is equal to map creator, And here I have to specify the types. So I want to make a map of integers as keys and strings as values. And open the constructor, and within the constructor I have to add a list of integers because I specified the type here to be an integer, and the second list must be of type string because I specified string here. So I'm going to say list of 1 2 3 4 5 for the list of integers, then list of 1 for the string, 2 3 4, and lastly 5. And whenever we're done, we are going to call the get map function. So the get map returns a map, so I'm going to save it into a variable. Val my map is equal to creator, which is the instance, then get map. Now I get the map here, and I want to print it to verify my output. So I'm going to print my map, and now let's run the program. And here comes the map. So 1 is mapped to 1, 2 is mapped to 2 string, 3 is mapped to 3 string, and so on. And as you can see, using generics in a class or a function makes the code more reusable, as we can also make the keys of type double, so 1.2, 2.3 maybe, 3.4, 5.5, and 5.0. And the only thing we got to do is just to change the type from int to double, or maybe just get rid of these because the compiler will infer the type for us. And if we run again, we can use it with other types as well. That was it for the first part of generics in Kotlin. Stay tuned for the second part where we go into more details about generics. So for now, thank you for watching and see you in the next one.